triangles. This is not the Rockaware sign, that's a triangle brought to you in part by math, killing people's brains for years. Alright, today you're going to understand what a triangle is and why its interior angles equal 180 degrees. We're going to use our knowledge of triangles to identify missing measures algebraically. We're going to understand what an exterior angle is and its relationship to remote interior angles. We will use our understanding of angle theorems to identify missing measures given an exterior angle. Okay, so like we talked about before, this is a triangle. We know that this is a triangle, and we know that it has 1, 2, 3 interior angles. And if we add them all up, they're always going to equal what? 180 degrees. To find the missing measure of a triangle, if we're given two measures, or sometimes just one measure, to find the missing measure of a triangle, we can set up an equation using the angles we already know, kind of like we did when we cut parallel lines with the transversal. Because we know if we're given two angles, and the other one is represented by a variable, right? We know that all three of them together would have to equal what? 180. So couldn't I set up an equation with a variable, two numbers, and set it equal to 180 to solve? I absolutely could. We're setting it equal to 180. For example, I have this triangle here. In this triangle, I'm given two of the angles. They do not tell me the third one. But I know that all three of these have to equal what? 180 degrees. So I can set up an equation. I can take x, and I know if I add it together, all three of them, they'll equal what? 180. So I take x, add it to 155, I set that equal to 180. Some people can do this in their heads. I want you to understand where writing the equation is important. Do you think they're all going to be this simple and easy? No. Get in the habit of writing them like this for the easy ones because they do get a little more difficult. Yes?
Couldn't you just add them and then subtract them from 180?
Get in the habit of writing equations because they do get a little more difficult. Get in the habit of writing it like this. This is like a one-step equation. If you want to call it like easy, they get harder. So if you don't know the rules here for how we would set it up, it's going to be a struggle later on. Don't take shortcuts here, okay? I'm suggesting you don't, because it gives you practice for the harder ones. So we add these together. We get x plus 155 equals 180. We subtract 155 from both sides, and that gives me what? X equals what?
25.
X equals 25. You should never get this wrong, because you can always go back and add them all together, and they have to equal what? 180. If they equal anything else, you did something wrong. Figure it out. All right. Let's try another one. So here we have another triangle. Once again, we are given two angles. We are trying to find what? Angle C. So we can write an equation for this. Let's go to Mr. Dean. Mr. Dean, what equation can you write for this triangle?
C.
C or X or any variable, yeah, it's fine.
Plus A, right?
Well, what is the measure of A?
42 degrees. 42.
So a variable plus 42 plus
Plus 63.
equals?
Uh,
Every triangle has to equal how much?
180.
Boom! There it is.
Okay.
180 degrees. I use X. I like to use X for my variables. It is what it is. You can use C. You can use any variable you want. I'm using X. So we take X. We're going to add the other two angles together. On the left side of the equation, all that's set equal to 180. When I combine my terms, I get X plus 105 equals 180. Julio, what do I do now, man, to solve this? One step left, man. What you got?
You subtract 105 from 105 from 180.
Perfect. And just Julio. Just Julio. What's that going to give me? Go ahead, man. Take time. This is a one-on-one class. After this slide, you will have a whiteboard, just FYI. Second slide is also a one-on-one, then you'll have a two-on-one, okay? 75. Boom! X equals 75, and you can self-check this. You can always go back and see, do my angles add up to equal 180? Yes, they do. They do. Scary voice. They do. Any questions on how to find the missing measure of a triangle? Got it. Anybody? Going once, twice. So now, let's complicate things. Why not? But it was so easy a slide ago. Why you gotta complicate it? Because that's math. Math is complicated as it goes up in like difficulty level. Yes. Why? Because people who wrote math like to torture you. Really? No, it just gets harder. Okay, so we can also set up equations using angle expressions to find the missing measures of a triangle. So in the previous slide, we were given 2 degrees. We were finding just one missing variable. Here, though, if you look at this triangle, you're given an expression for each of the angles. So angle U is represented by 2x plus 5. This is 5x plus 3, and this is 7x plus 4. This is similar to what we were doing last time. Same process, though. We're still going to set everything equal to 180 degrees and solve. It's easiest, and I want you guys to pay attention here. This is the easiest way to set this up and combine these terms. To use something known as a vertical arrangement. People that use this arrangement make a quarter or a tenth of the mistakes as people who just try to add them all up one by one. And here's what a vertical arrangement means. It means you take each expression and you stack them on top of each other. 1, 2, 3, doesn't matter the order. X's over X's, constants over constants. Why is this easier?
So we can add them together.
You can add them together, straight down the line. 7, 5, and 2 make 14. 4, 3, and 5 make 12. If you put them side to side like this, let's just say, these aren't the expressions, but let's just say that these were similar, something like that. Well, that's a plus there, 3x minus x, and then 4x plus 2. It starts to look a little more complicated. You start forgetting you added stuff up or not, like, wait, hold on, add that, da, da, da. So, vertical arrangement, easiest way to do it. Stack the expressions on top of each other. Just make sure you don't mess this up. Variable terms go over variable terms, constants go over constants. I also teach you this here because when you get to Algebra 1 next year, you're going to see this word again, vertical arrangement. It's going to help you a lot with something known as polynomials. Don't worry about it now, but it will help you a lot later on. So we stack these, we combine our terms. We end up with 14x plus 12 equals 180. So all this hullabaloo here has turned into this, which is a 2-step equation. 14x plus 12 equals 180. Everybody in this room knows how to solve that. You subtract 12 from both sides. That gives you 14x equals 68. Then the last step, you divide out the coefficient, you divide both sides by 14. That's going to give you x equals, anybody? 168 divided by 14. X equals 12. X equals 12. Once we know what x equals, the rest of the process remains the same. You're going to take that, and what are you going to do with it, class? Substitute it back into each expression. So we substitute into this one for t, for v, and for u. 12, 12, and 12. We do our multiplication. We do our addition. And that's going to give us 3 different angle measures. 88, 63, and 29. If you did it correctly, these 3 angles should equal what? 180. If they do not equal 180, it's wrong. You can self-check this. If I add these up, they do equal 180. Any other number substituted in here will not give you 180. So always, when you're doing this, check your work. They should add up to 180. Always. Yes? Always. When you're doing this, interior angles of a triangle. Always 180. Okay? Questions on the first one? I like the second one here because I know how much all of y'all enjoy fractions. You're like, fractions, yes, 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 fractions!
No.
Woo! Nobody did that. Nobody in here.
Yay.
But it's the same process. Vertical arrangement. We have no constants. It's a variable term. Now be very careful. This is n, but what invisible number is next to n? 1. Little 1, right? Oh, I have my marker. Little 1, right there. So when you stack them, does it matter which order I stack them?
No.
No, it does not, because when you add numbers together, 3 plus 4 makes 7, 4 plus 3 makes 7. Doesn't matter. Just make sure it's always variable terms on top of variable terms. So we have 1 in, 1 half in, and 1 half in. So think about it. It's like you got $1, 50 cents, and 50 cents. You put them all together, what do you have? 2. 2 in equals 180. This is pretty simple to solve. We're going to divide both sides by my coefficient, which is 2. That gives me n is equal to 90. Which is great, because I already know that this is 1 in. So 1 in just means that this is 90. These are each a half in case you don't know how to get this. Let's just do it here. Half of 90, in case you can't split it, you can multiply, because it's not always going to be a nice even number like this. 1/2 times 90 over 1, that's going to give me 90 over 2. Quick division says that this is going to be 45. So this is 45. This is 45. Self-check. 45, 45, and 90 equals what?
180.
Boom! There it is, baby. That's what I'm talking about. 180, son. Questions? Questions? Huh? Any questions? No? Okay. The last part of the lesson. We talked about interior angles so far, but now we're going to go outside the triangle. The exterior angle theorem, triangles is what we're talking about now. It states that a triangle's exterior angles are equal to the sum. What does sum mean? What operation? Addition. Equal to the sum, the addition, of its two remote interior angles. Like, well, great. Go ahead. Get me some stuff I don't know. Exterior to remote, what does that mean? Remote control? Am I going to go in my DVR and pick out some answers? No! Here's what it means. In this diagram below, right here, angle 4, is it inside the triangle or outside?
Outside.
It's outside. So it is an exterior angle of the triangle. So we're there so far, right? We're talking about exterior angle. We're dealing with this right here. The word remote in this context, and I hope you pay attention, because if you get it right now, you're good. If you mess it up right now, it ain't gonna be pretty for you at all. The word remote in the context of two remote interior angles means the two angles. How many angles in a triangle?
2.
How many angles? There's 3. We're talking about the two angles that are not next to angle 4. What angle is sitting right next to angle 4? 3. So we ain't talking about that one, man. What we're talking about is angle 1 and 2. Because angle 3 is next to 4, it is not a remote angle. The two angles that are remote angles to 4 are going to be the one that is not right next to it. So the remote angles to 4 are 2 and 1. And what that means is this. It means that if angle 4 measures 110 degrees, these two angles here, if we add them together, what do they have to equal? 110 degrees. So the exterior angle is equal to the sum of its remote interior angles. Remote means away. If you're telling me that 3 is far away from angle 4, look a little closer. These go away. These are far away. This is close by. So, and I say this over and over because it's a common mistake. 3 has nothing to do with the remote angle. 3, technically, if you want to know what it's called an adjacent angle. Adjacent means right next to. Adjacent. So this, remote. So we add these together, they would equal 110. And as a follow-up question to that, there's 2 different ways you guys should be able to tell me the measure of angle 3. You can use triangle theory, which we did today, or you could use half circle or straight angle theory, but all of you should be able to tell me that angle 3 equals what? 70 degrees. Good job. 70 degrees. All right, so let's take that piece of knowledge, that little nugget, and let's ask a question about it. What's up?
You didn't fill in those blanks.
Which blanks?
1 and 2.
Yeah.
1 and 2.
Okay.
And what about this blank right here? Boom! Yes, 70 degrees.
See, I didn't know there was a blank.
I already knew it. Yes! Hercules! Hercules!
So we're taking this nugget of information. It goes into the brain, hopefully not out the other ear. And then we are to use it for this. Okay. So when we had angle expressions before, we were only talking about, and hopefully you pay attention, you've got to realize there's a divide here. When we're talking about the interior angles, just the interior, you're always going to set your equation equal to what? 180. Here we're not talking about interior angles exclusively. Here we have stretched this out, and we're talking about remote interior and an exterior angle. So here I'm given an exterior angle. I'm told this is 100 degrees. I know that this is 40. I don't know what this is, which means to solve it, I'm going to have to set up an equation. But I know I'm not setting it equal to 180 because we're no longer inside the triangle. So what can I set this equation equal to? Yeah?
100.
100 degrees is correct. Because if we add these two together, they have to, listen to me carefully, if we add these two together, they have to equal what? 100 degrees. Okay, so our equation, still vertical arrangement, 2x, notice there's nothing here, right? Because there was no variable term. So 2x plus 10 over 40, vertical arrangement. The reason I do this is because sometimes it gets a little bit bigger. So just get in the habit of vertical arrangements. We combine them. We get 2x plus 50. That is being set equal to 100. Because I know that these two angles together equal 100 degrees. Not 180. So be careful. That is the most common mistake. Oh, it's a triangle, so it's always 180. Only if you're inside the triangle. Once we go outside, we're setting it equal to the remote angle. You with me? Alright. Then we go and we solve it. We subtract 50 from both sides. That leaves us with 2x is equal to 50. We divide out the coefficient and I get x equals 25. Yes?
What happens if you don't get the 100? Like if they don't give you the 100?
You'll always be given enough information to solve it. You'll always have something. This could be an expression, and maybe you have these two, right? Something like that. But either way, you'll have enough information to solve it. Just realize that when you're dealing with the remote angle, you're going to set whatever's outside equal to the two angles on the inside, the remote ones. Yes?
So are we not working with the angle number like 3? Is there not a third angle?
Well, you have angle 1, 2, and 3. You're not being asked to find this one, but if you were asked to find this one as well, you could, right? Because if you were to solve this and this, using triangle theory, interior angle theory, you could find this, right? Or, even easier, straight angle or circle theory, if this is 100, what does this have to be? 80. You get the idea, right? Okay. And technically, there's another way to solve it. If you know that this is 100, that means that's 80. Aren't we just then dealing with the inside of a triangle? Ah, you are. So there's more than one way to solve these. Right now I'm teaching you guys how to solve them when they're outside, because you're given enough information to set it up quickly on the outside without having to use circle theory or straight angle theory to find this angle. Using just these three terms. 100, 40, and 2x plus 10. That's all the information we need. We got, disappeared, where'd you go? Come back. X equals 25. So I can go in, once I know that, and I will substitute it in to x. That's going to give me 2 times 25 plus 10, which gives me what? 60. This is also self-checking. Whatever you get here, if you add it to this, what does it have to equal? 100 degrees. 60 and 40 equal 100, so that is the correct answer. If you were then asked to continue it and find this, well, you know what that is already, don't you? It's 8. Questions on the first one? Okay. So the first one, we just had one expression on the inside. For this one down here, we're going to have 2 expressions on the inside. Same process. We still know the remote angle. We know the exterior angle, and we're given expressions for the 2 remote angles. So when we set up our equation, does anybody have an idea what it is going to look like? Maria?
7y plus 6 plus 4.
Good. And we use our vertical arrangement, 7y plus 6 over 4y. You combine those, you get 11y plus 6 equals 116. When you do that, you should know how to solve it from here. Class, what is the next step?
Subtract 16 from both sides.
Subtract 6 from both sides to get the variable term alone. That will cancel out the constant here, leaving us with 11y is equal to 110. Maria's smiling like she's already finished this problem. So let's see, we divide both sides by the coefficient. I get y equals 10. Once I know what y is, it's just simple substitution, man. You're going to substitute it in here and here. Ba-boom, ba-boom. You do a little multiplication, you do a little addition. Self-check yourself. Whatever you get, if you add them together, they should equal what? 116. If they don't, you probably forgot to add right here. Most common mistake on this substitution is forgetting to add. Not most of you. A good percentage of you forgot at least one on the previous whiteboard to add when you substituted. Questions? Questions? Questions. Okay. All righty then. Don't forget to like the videos, leave a comment, share it with your friends, and of course, subscribe.